So now we can calculate variance and standard deviation. What does that mean? All right, so what I would suggest that you write down in your notes is this last statement. Okay, so that's kind of where we're going to start. It says that the larger the standard deviation, the more dispersed the data set is. And dispersed, if you don't know what that means that the numbers are spread out. Yeah, sure.
On maybe up to
At 10 o'clock. I mean, I have a couple minutes.
okay, so that come home with it, I can be confused.
Yeah, we'll look at that. Okay, so I'm going to give you, and this part I don't think you need to write down, but I want to explain just a little bit what we mean when we talk about something being dispersed or spread out. Okay, so I'm just going to jot some stuff down here again. I don't think you need to write this down. Just look for a second. So let's say that we have a data set that has a mean 20. Okay, so like when we added all the numbers up, we divided by however many we had, and we got 20 for the mean. Okay, and then if I look back at the original numbers in the data set, suppose that the numbers in the data set look like 19, 21, 20, 18, 22, 20, 19. Okay, so that's a data set that is not very dispersed because all of those numbers are very close to that 20. Okay, do you see that? They're kind of all gathered around the 20. So that's a data set that's not very dispersed. All right, versus.
Yeah, you gotta wait till it's close to checking. It's not something you can just do.
You know, 10, 45, 7, 32, 82. Okay, you still can get a mean of 20 when you add them up.
On top of these covers like this.
But those numbers are all over the place, right? They're very spread out. They're not close to the mean at all. So that's what we're talking about when we say that the data set is dispersed. We're saying that the data is either grouped around a mean, like it was in the first example, or it's just sort of all over the place, like it is in this example. Okay. All right, so we're going to start with that first rule that says that a larger standard deviation means the data is more spread out. And we're going to look at an example. All right. So let's write, I'm going to read it, but let's write this part, not necessarily the top part. All right, so the top part says, as you're jotting stuff down, I'll read it. It says a car salesman wants to compare the miles driven for cars on his lot. He wants to compare the Toyotas to the Hondas. So he calculates the following. All right, so like I said, let's jot this part down so that we have our data in our notes. The Toyotas, he calculates the average miles to be 67.5. So he goes out, gets the odometer readings off those cars, adds them up, divides by however many, comes up with 67,500. And he then calculates standard deviation using the formula that we talked about when we met Friday. And then he does the same thing for the Hondas. So he calculates the average mileage on those cars to be 64,000, calculates standard deviation to be 13.4. All right, and then jot your question down as well. So the question is asking us which data set had data that was more dispersed, which data set was more spread out. Okay, so if you remember your rule, we'll flip back there for just a second. We said that the bigger the standard deviation is, the more spread out the data set is. So if this question is asking me which data set is more spread out, the only thing that I need to look at is to compare the two standard deviations. Okay? And so which data set had data that was more spread out? You would say which one? The Toyota's 5. You're right.
Larger.
It's a larger number, yeah. So super easy. We look at this and we say, hey, the standard deviation here is bigger, so the Toyota data is more spread out. Right? Because it has a bigger standard deviation. So I'm going to write that down. Because it has a bigger standard deviation. All right, so that should seem really easy, right? I mean, you're just looking for the bigger number, and then that one's going to have data that was more spread out. All right, so let's look at another example. So this one says, I'll tell you what, let's don't write the problem. We'll write some information down, right? So I'm going to read it and let's write as we go. All right. So the first sentence says the mean of the number of sales of cars over a 3-month period is 87. All right. So let's write this. Let's write number of sales. And they tell me that the mean is 87, and the standard deviation is 5. All right, and I'm just going to do SD for standard deviation. Okay, so that's the first sentence. The mean number of sales of cars over a 3-month period is 87, standard deviation is 5. All right, next sentence says the mean of the commission data, so he's going to compare sales to commissions. Is 5225. And the standard deviation is 773. Okay, so just in your notes, be sure that you jot down your information there. Right, and then they basically want to know the same thing. Which data set is compared variations? That basically means which data set is more dispersed. So I'm going to argue that this is not quite as easy as the last example. Okay, that I can't just look at my two standard deviations and say, oh, 773 is much bigger than 5, so therefore that must be the commission data being more dispersed. Okay, so now we need to figure out what's the difference. So why does our rule work in the first example, but it maybe doesn't work here? Okay, anybody have a thought? Why it's fine in this example to just pick up the bigger number, but then when we're talking about the commission data and the number of sales, we can't do that.
It's not talking about the same thing.
You're not talking about the same thing, okay? So as long as you are talking about exactly the same thing, mileage on one car versus mileage on another car, you can make that really easy comparison. But the minute you start talking about two different things, okay, these things don't even have the same units. Like number of sales is something that I count 1, 2, 3, 4, 5. Commission data would be money, right? So I mean, we're not even talking about the same two things. We can't make that direct comparison. Okay. All right. So somewhere in your notes by this problem, let's write that issue. So let's say that we can't compare the standard deviations if the I make it as easy as possible. Let's just say the two things are not the same. Okay, so the way that we're going to deal with this is we're going to convert both of these things to the same thing. We're going to pick something else, and we're going to make a conversion for the number of sales, and then we're going to make a conversion for the commissions, and then they will be the same because we're converting them both to the same unit. All right, we're going to come back to this problem in just a second. All right, so this thing that we're going to use is what's called a coefficient of variation. All right, so when do we use it? We're going to use it when we want to compare two standard deviations. And they are not the same. We'll just put unit next to that. Okay, like what we just saw with the commission and the money and the number of sales. All right, so coefficient of variation gives us a formula that we can use to convert both of our items to the same thing. All right, so that formula looks like it has an S on the top, it has an X bar on the bottom, and it's multiplied by 100. Probably need to think about what those symbols in the formula stand for. Okay, so do we remember what the S stands for in a formula? Remember that? We talked about that on Friday, the S.
Does the S just stand for regular standard deviation?
It's regular standard deviation. Remember the S squared is the variance. The S is going to be your standard deviation. Okay, and what about the X with the bar over it? Remember that one? That's been a little bit longer. That was 3-1. That's your mean. Okay. All right, so this formula is saying that we're going to take our standard deviation on the top and our mean on the bottom and divide it out and then multiply by 100. All right, so I'm going to go back to our example and we're going to look at doing that. All right. So I need to do it for both the number of sales and also the commission. All right, so for number of sales, remember standard deviations on the top. So we're going to put the 5 on the top of the fraction, 87 on the bottom, and then multiply by 100. All right, that gives me 5.75. I'm going to put it in my calculator. And then I'm going to do the same thing for the other one, for the commission. All right, so again, remember formula says standard deviation on the top. So that's the 773 over the 5225 times 100. So that gives me 1479. All right, so now we have the standard deviations, so to speak, in the same unit. They both have the unit of coefficient of variation. So now I'm going back to my rule, and I'm comparing those two numbers. And I'm looking for the larger number to indicate that the data set's more spread out. All right, so I would say that the commission data is more spread out because the coefficient of variation is larger.
You don't have to round, although.
You should round to 2 decimal places. I may have done it wrong. Hold on, I'll look. Coefficient is coefficient of variation. It's larger. All right. Let's see.